Hello, college algebra student. This video is for chapter 5.5, Zeros of polynomial functions. So we like to solve the x-intercepts of a polynomial functions. Zeros are just x-intercepts, so it helps us to find out how to graph it. And also if we have a work problem that involves a polynomial function, we know how to solve it. So we have two theorems that help us that's related to finding zeros of polynomial function. The first is called factor theorem. What is factor theorem? Factor theorem is the fact that you can find that x minus k is a factor if you divide it if you use f of x if you divide it your f of x by x minus k, and you get a remainder 0. Because if you can factor it, you should have no remainder. So to show that x minus k is a factor, you would use synthetic division to divide it and check if the remainder is 0. So the example would be, okay, I like to factor this x cubed minus 6x squared minus x plus 30. I don't know what the factor is because I want to solve it maybe. So if someone suspect that maybe you can check x plus 2, maybe it's a factor. So I'm going to check, just show that it is or it is not a factor. So what I do is I will try to divide it and see if I have 0. It's very similar to if someone say, oh, I have a number 15. I don't know if 3 is a factor. So you can just do 15 divided by 3. Oh, it is evenly divided it out with no remainder, then it is a factor, right? It's a factor if you can divide it. So it's the same idea. I want to check if x plus 2 is a factor, so I use synthetic 1, negative 6, negative 1, 30. There's no missing term. And then x minus k, so I would use negative 2. So bring down 1. 1 times negative 2 is negative 2. So I would have add is negative 8. Negative 2 times 8 is 16. If I add them, it's 15. Negative 2 times 15 is negative 30. Okay, at this is 0, so the remainder is 0. Remainder is 0 just means what? You find a factor. So yes, x plus 2 is a factor. If so for some reason you cannot, then you say it's not a factor. Now, the interesting thing is also the remaining quotient is also a factor. So you'll find x plus 2 a factor, and you'll find this. And you can then completely factor this polynomial. Example 2, check that x minus 2 is a factor of x cubed minus 4x squared minus 4x minus 16. So to do that, I check x minus k. So k is 2, right? So draw the synthetic division box. I write 2 outside. 1, 4, negative 16. Bring down the leading term. 1 times 2 is 2. Add them is 6. 2 times 6 is 12. Add them is 8. 2 times 8 is 16. Oh, it is also 0. So you would say yes. X minus 2 is a factor. And what's the other factor? The other factor will be the other factor is the quotient 1x and x squared, so it's x squared plus 6x plus 8. And this is factorable, so that's how you find all the factor. So it all started if you have an x cubed. Someone gives you a hint that x minus 2 is, you find another factor which is a quadratic factor, and you can factor the quadratic factor by diamond because it's quadratic. So then you can find all the factors. So that's the idea. But it turns out you always have to start 1, right? You have to, how out of the blue, how can I tell which one is a factor? If someone tell me one is a factor, then I don't have to do. Sometimes I don't have anyone that can tell me, so what should I do? So there is another theorem called rational zero theorem. Rational zero theorem say if f of x has a rational root, that means if k is a root, so that x minus k is a factor, so then k is a zero. All these zeros must be in the form of, all this rational zero has to be in the form of p over q. Rational means it's a fraction. So whether the top is a factor of a0, which is the constant term, and over the factor of an, which is the leading term coefficient. Constant term and leading term coefficient. So, and then you would figure out, make a list of possible zero. And then from the list of possible zero, you just guess which one is the correct one. So let's say list all the possible rational zero of 2x4 minus 5x cubed plus x squared minus 4. So those are the possible ones. So just remember, they does not necessarily are factors, because this list is really long. But if there is a rational zero, it would be one of those. So let's see. We would say it is p over q is equal to a factor of the constant term, 4, negative 4, and factor of 2. Now, do not cancel. You just list factor of 4. What is a factor of 4? Plus and minus 1, plus and minus 2, and plus and minus 4. What is a factor of 2? It's plus and minus 1 and plus and minus 2. So then what is the possible list? If the denominators is all 1, then I have plus and minus 1, plus and minus 2, plus and minus 4. If the denominator is 2, then you just put it in. Then I could have plus and minus 1 half. Plus and minus 1 is already done. Plus and minus 4 over 2 is plus and minus 2 is already done. So these are all the possible zeros. And so you would use those to check if any one of them are factors. So that's how you start the factoring process. Another one, list all the possible rational zero of 3x cubed plus 4x squared minus 2x minus 1. So I would write here p over q, factor of the last constant term, factor of negative 1, that include also positive and negative. And then in the denominator is factor of 3. Now, factor of negative 1 can only be plus and minus 1. Factor of 3 would be plus and minus 1 and plus and minus 3, right? So it ends up, what is the possible one? Would be having the denominator equal to 1, so it's plus and minus 1, and having the denominator equal to 3, so plus and minus 1/3. So now I can actually check. Oh, maybe I'll check if 1/3 is. Okay, so 3, 4, negative 2, negative 1. I haven't done an example where the zero could be a 1/3. It could be a fraction, so I'm going to do one. Let's check. So bring down, so this times this is 1. You add it, so that would be equal to 5. 1/3 times 5 is 5 over 3. 5 over 3 plus negative 2 is negative 1/3. Negative 1/3 is times that is negative 1/9. That is not 0, right? So that one is not a factor. But let's check negative 1/3. 3, 4, negative 2, negative 1. Bring down, so it's negative 1 is 3. 3 times 1/3 is negative 1, so it's negative 3. Negative 3 times 1/3 is 1, 0. So I check that k is negative 1/3 is a 0. So it is possible. So it could be not, but it is in the list. So you just have to check all the possible is a 0. If it is a 0, I find x minus negative 1/3. That means x plus 1/3 is, and also I can find the other factor, which is 3x squared plus 3x minus 3. These are also factors. So you actually fully factor the original polynomial. So that is the use of listing all the possible zeros. Sometimes you would go through the list. There's a long list, and you're not lucky. It takes a while. Okay. So we'll do in the next video, we'll go through this process in details on how to find zeros of a polynomial function. Basically, you would use the rational zero theorem, list all the possible ones, check them one by one. Sometimes you're lucky, you get one right away, and then you get the quotient as the other factor, and you check, and then you factor the quotient also. Okay, so that's the